Thanks.
Kia ora kutu is the level 1 thing is kia ora, and then you can add. In English, you can say hi y'all, which is kind of non-standard, but hi y'all is kia ora kutu is I understand. This work I did when I was here in 2020 with Jens Dietrich and David Pierce, who walked in here. At the time, he was with Vic. Now he is no longer. He's now with Consensus. I'm still at the University of Waterloo. They didn't fire me, and Jens is with Vic UD. Software use is here. And so this is moduleaccount.com, and NPM, more than a million modules, or things that are kind of as simple as left path notoriously, but also things that are more complicated. You're like, well, maybe NPM is an outlier, but other things as well. Maven Central for Java has 350,000 packages, right? So you want to write something, and when I was 20 and I was writing code, it's like, well, maybe I did 5 dependencies, and this is not what people do now. So what does that imply? Well, you have your packages, and your packages get updated from time to time. And so now you have this problem, and it's kind of like a Scylla and Charybdis problem. And so either you bash into the wall of upgrading too late, or you get sucked into the vortex of upgrading too early. And so these are both bad in different ways. And so if you upgrade late, what I kind of tell my students is, in Canada, you never want to be testified before a royal commission. It's just not, this is not good. And so if you're the Equifax CEO, it's kind of oversimplifying to say they forgot to upgrade and then they got hacked and then you got called for Congress. But basically, that's at some level that's kind of what happened. So he didn't upgrade his some minion 6 levels down didn't upgrade the software, and then here he is, right? That's all. And of course, you're like, okay, fine, I will be the eager beaver and upgrade early. Well, no, that takes too much time, and so you have finite time, and you can't. If you just upgrade all your things, then it doesn't matter. It's a form of tech debt that doesn't wait for you. Tech debt that just kind of advances without you, and tech debt doesn't matter if you actually declare bankruptcy. So the vision then is, how can we make upgrades less painful? Right? And so formal semantics of version numbers, well, that's not quite what we're doing. We're just going to have some very hand-wavy ideas about what version numbers are, but let's talk about that. Semantic versioning, and the hand-wavy version is that it's 3 things that are usually, but not always, numbers. We'll use numbers here. You have major, minor, and patch. And the semantics that are specified informally are as follows. You have major version number. In theory, what's supposed to happen is when you make a breaking change, that is, if some dependency is going to be broken because you changed your library that they depend on, you're supposed to increase the major number. The minor number is, well, you added some functionality. It can do all the things it did before, and it can do something new. And then patch is it has the semantics you originally meant to do, but you had some sort of bug, so you fixed it. And so it actually has different semantics, but you're not supposed to be able to say that. So I said that, and that's not actually what happens. What actually happens is you make some change, and you're like, well, I'm not gonna. It's actually breaking, but no one is really gonna care, so I'm just not gonna increase the major. Or yeah, things like that happen, right? And what we want to do is some way of understanding changes that is better than just this number that is specified arbitrarily by the upstream developer. And so in some sense, we can think of this as some sort of simplified contracts. What the software is supposed to do, you can specify it in a contract. And so what the software is going to do in terms of versioning, the changes between the versions, you can think of that as some sort of simplified contract language. And so the thesis behind this was an onward essay. And so the thesis behind this essay is that the research community has a key role that it could play, if it chose to, in developing relevant tools to help developers cope with upgrades. Right? It's like, oh crap, my dependencies are upgrading, what am I going to do? And so I think that there are some tools that exist. We can do better using our understanding of program analysis. And so it's opportunities for all. if you're a Mars rover especially. So I wanted to talk a bit more about understanding upgrades. And so I try to understand why people do things. I try to think, well, people aren't just doing things because they're dumb, right? This is usually not what's going on. And so let's try to understand why upstream developers break things. And so, yeah, it's not quite true that ostriches stick their heads in the sand, but there is a certain amount of ignorance, or they just didn't think of that. So you have your software as an upstream developer, and you're like, oh, well, I'm just going to rename this because it's better. And you didn't think that people actually use that. So like, to a certain extent, you might inadvertently make changes that break downstream packages. So of course, we believe that evolution is a thing for animals. It's also a thing for software, not just animals, but all life. And software isn't alive, I guess. But certainly, as a developer of software, you have incentives to change the functionality of your software in some way. And so some of these changes are going to cause breaking changes because the software would really be better if you did it in a certain way. And you don't really necessarily always want to have backward compatibility, right? So it's like you want to make your software better. Sometimes you're going to break something from doing that. So that was kind of why maybe sometimes people break stuff in upstream. And then the other question is, how do people break stuff in upstream? And this kind of how is maybe not the right question, but it's like, it turns out that there are different community norms when people do break things. And so it turns out that in NPM, then the norm is you're supposed to, when you make a breaking change, you are supposed to increase the major version, and people will usually do that. In the R community, then you're supposed to notify people, hey, I'm changing things. And in Eclipse, it's like, no, you're not supposed to break things. It's like a community norm that you do not break things when you upgrade your software. I'll give an example of a breaking change in font config just to see how breaking changes actually happen. And so one fine day, font config got upgraded, and then if you upgraded, so font config is this library that you use to select fonts. So I'm like, I want font Arial. And so then I ask font config, hey, tell me where Arial is located. And font config tells you, okay, this is, you look at this font, right? And so one fine day, Firefox did not render Arial properly. And why? It's because there was a function that was underspecified such that if its input was empty, it used to work. It used to have some default. And then they're like, nah, no one would ever do that. And so they changed the behavior of font config such that it would no longer work with the default. And then it broke Firefox. So there had to be, basically, as a client, Firefox had to deal with this breaking change in font config. Okay, so we talked about upstream and upgrading. So let's talk more about the consequences of upgrading late. And I gave the brief summary. Let's talk about it a bit more. And again, the worst case is you get called for progress and you get to the opportunity to explain yourself before a not very sympathetic audience. So in particular, what that means is that you are vulnerable to external bugs. And so you depend on some software. And that software has bugs. And they upgrade it, and so you better upgrade reasonably soon after the upgrade, especially if it's a zero-day vulnerability, right? And so you don't want to be up for too long. So there's a question about how often you want to upgrade your vulnerabilities or your dependencies. So like I was thinking about this in the context of LLVM recently. And LLVM is a super fast moving target if you have some software that has an LLVM. And so there's kind of this low-end cycle, right? So it's like, okay, so LLVM changes every 6 months or something like that. And so, okay, so you have your research prototype and you're just chugging along at it. And I guess you're chugging along at it, then every time LLVM upgrades, you also do the thing. And it's kind of tactical if you do it like as you go along. But then, like, you know, the student graduates, and then 2 years later, you want to pick up that research prototype you did again. And then you're like, oh no, now I have to look at all the things that changed in the last 2 years, and that's, oh no, that's terrible. And you just give up and do something else. True story. Sad true story. So why is upgrading early hard? Right, so you have priorities, right? You better do something. Because your boss is like, look, you got to do this right now. And so you're like, but I want to upgrade my libraries. And your manager's like, yeah, whatever, just go implement that feature, right? So it's one thing that you can do, but there are things that are maybe more important than upgrading your libraries. If you have to fix your own internal bugs, maybe that's also more important than upgrading your libraries. Sometimes you know there's definitely something bad, but sometimes you don't know. And so you know that your bug in your software is definitely bad and you have to fix that. And so maybe that will take priority over the thing where you upgrade the dependencies, and maybe that helps you, but maybe it doesn't. You upgrade things and then you don't know what's going to happen, right? So I alluded to that with Firefox. You upgrade your software and 99% of the time it's going to work, but sometimes it doesn't. And then you're like, oh, oops, playing with fire. And it also might be the case that it's actually hard to upgrade your thing. So like you have this, let's say, Android app that you're trying to rebuild, and it turns out that every time you rebuild it, it takes a day. And so maybe your continuous integration isn't quite good enough. So upgrading might be just kind of painful. So unlike the tooth fairy, automated upgrades are a thing. And so that's great. But like my Chromebook was like, hey, I just upgraded. Do you want to reboot now? I'm like, no, I don't want to reboot now. So they can auto break your code. And so in another paper, Jens Duschek was saying, you begin to realize how sloppy upstream people are and the issues it causes. So you get a bit more cautious about upgrades. Right? And so they come at a cost. You have to pay this cost when you upgrade software. Sometimes you don't have to pay it. Sometimes it's great. Sometimes it's not great. Okay, so we talked about upgrades and the great choices you have either way if you upgrade late or if you upgrade early. So is there a better way? Let's talk about how we can reason about upgrades. And so software behavior, right? Basically, we're talking about software behavior. And in principle, you might imagine seeing the change in behavior as a change in a contract. Now, I think in 2022, there's kind of zero contract systems which will capture the effects of most upgrades at least. So I think currently I would characterize that as a dream, nightmare, something. But conceptually, you can imagine contract languages that are somehow specialized to deal with upgrades. So in principle, what could happen is you could have a contract C before the upgrade, and then a contract C prime after the upgrade. And there are tools that don't really do things that are that relevant to upgrades, but there are tools that reason about contract-like things like infer. Rendup and QuickCheck are also tools that reason about software in a way that is relevant to the kind of things that I talked about. They don't do really that, except to some extent with like null checking. That is a thing that is kind of relevant. But another aspect about reasoning about upgrades is talking about the API service. And so what do I mean here? So, right, so there's an upgrade in your dependency. Your dependency has 1,000 classes that it exposes. And it's going to actually upgrade class C in its API service. And it turns out you only use X, Y, and Z. So it can actually be totally fine. You upgrade it and you know that it's actually gonna go fine. And so the question is, which changes are relevant? So maybe you want some sort of tool that is going to tell you, this upgrade is fine, really, no, it's fine, and it's not gonna affect you. Whereas that upgrade is like, maybe that might actually affect you. And so how do you know how much of it is gonna affect you? So as an upstream developer, I was kind of talking downstream, let's shift to upstream. If you want to try to be an upstream developer, how can you be a responsible upstream developer and not screw over your clients? And so you can make a sort of open world assumption. Note that we are not on this map. It's like, there's kind of this thing, maps about New Zealand. It's like, no, there's not. So you can kind of think, well, maybe everything that I expose is going to be held. So that's one way of looking at the world. And it's really frustrating to do that because then you can't change anything, right? It's like you imagine that somebody's invoking all the things. Like, oh, well, it's actually too limiting. You can't do that. So maybe you want to limit the API service and you want to use some sort of module system and you say, look, only certain things are called. And so you do a closed world assumption, which is no longer the case, for better or for worse now. And so you might, one way of thinking that is like, you're like, look, I am the library, and in fact, I only care about these 4 clients. This could actually be a real thing if you're developing in a company and you're like, okay, only these 4 clients matter. So that's one way of allowing you to do more better changes. So I understand the monorepo kind of has that, right? The Google one. It's like, well, you can make a change, but then you can also change all the clients that you have. So that's one way of doing things. I wrote this, and then I'm like, no, actually at limit there's 0 clients. And so then you're like, it's great. You don't have to worry about that. But you can also specialize to just 1 client as well. So I talked about modularity. And so this is, actually I think after Rapoka has CodeView, so QBasic. But it is not the 90s anymore. And in some ways things have changed. And we actually do have bigger systems and more modularity mechanisms at our disposal now than there were in the 1990s. Okay, so I wanted to talk a bit about a taxonomy of changes. And so that's just a quick part. And so it's understanding what changes might happen, so to have some sort of vocabulary to reason about it. And so what you might actually do if you are an ecosystem is you can say, look, I'm going to allow these kinds of changes, but not those kinds of changes, right? And so Eclipse might say, oh, I'm going to actually allow 0 kinds of changes. They might agree for that as a community. Whereas like NPM might say, well, we're going to allow changes that, for instance, we're going to allow structural changes. So we can say, look, you can change function parameters, but we're not going to allow behavioral changes. Right? More likely to be the opposite. Like you might say, we are going to automatically scan for this kind of change, so we're not going to allow it or disallow it, but not allow this kind of change. And so they can. So why am I talking about taxonomies? I think it's a useful thing in the context of this essay. It can inspire tool development. So you can be like, I'm going to develop a tool that attacks this part of the taxonomy. It's like I'm specifically looking for something that does behavioral changes, which is hard, but that's kind of the thing. Or we can talk about another tool which specifically looks for structural changes, which is easy. It's like I'm going to look for methods that change names. So that's a tool that does exist, for instance. And yeah, so they express social contracts, right? The NPM community has one social contract. The R community has different social contracts. So taxonomies can allow you to express that kind of thing. So the main point of this essay is we think that there should be better tool support for handling upgrades. And so this is a copy of the Treaty of Waitangi, which is the thing that the British came and had Maori chiefs sign 150-ish years ago. And so it was, can we really say that was a collaboration? Maybe not. But upgrades are also maybe a collaboration between upstream and downstream software developers. And so what are the dynamics in that kind of system? So here you have upstream, and if you're lucky, upstream is going to flag some changes. It's like I changed X, Y, and Z. And okay, so if you're lucky, upstream did that. And then downstream, you're using upstream. So you get something out of it. You get to use the services in the library that upstream provided. But in the end, you have all the responsibility for dealing with all the changes that upstream made, right? So your system might be broken by the things upstream did. And so there's semantic versioning today. It has limitations. Basically, it's just 3 numbers, and you have to trust upstream. Do you want to trust upstream? Well, I'm just writing research software, so sure, I'll trust upstream. Do you want to upgrade upstream if you're writing like mission critical software? Sometimes people say it's a lie not worth the business risk. And so the vision that we are espousing in this essay is that upstream should signal changes in some sort of language, and the changes that upstream will signal can be verified using tools, right? And the tools, this is in some sort of machine readable format. And so downstream can then look at the certificate emitted by upstream. It's like, look, upstream said they changed X, Y, and Z, and also they produced this evidence that X, Y, and Z changed, and only X, Y, and Z changed. And so that can give declarations of breaking changes and check compatibility in the context that downstream has to deal with. And so what is the role of tools? So there were issues with tools. It's the usual, I kind of think a lot about static analysis, the usual static analysis issues. So you might, as a tool, you might miss some breakages. So you're like, yeah, everything's okay. Is everything okay? Well, no. Right. Or you might be like, oh no, everything might be wrong. And so that's no good either, because then the downstream developer is stuck with checking that nothing is indeed wrong. That's a pain. So as an example of something that a tool does right now is there is Rev API, which is, they say it's an API analysis and change tracking tool. And so I'll add the words unsound and imprecise. That's facts, right? So it detects semantic version number changes. So let's say you made some change and it's actually breaking, then Rev API is going to say, well, you actually did this breaking change here. You renamed this function. Right? So that's a tool that gives you something, and it is probably better than nothing, but there is so much more that we could do. And so in terms of recent progress, which I think is why, well, 2 years ago, this was a great thing today, and I think it still is a great thing today. So we have more scalable static analysis that has been developed over the past few years. So we have things that actually analyze, millions of lines of code. I have incremental static analysis as well, so that helps with scalability a lot. Fuzzing helps reasonable programs, and so we can reason about changes in programs in particular, and hybrid dynamic and static analysis as well. So our overall vision is that when you release a new software version, you should also be able to release a certificate or a passport saying, look, this is what changed in the software. This is how I know what changed in the software. I ran tools X, Y, and Z. And downstream, when they have to make an upgrade, they can consult the list of changes and say, yes, this is actually the things that changed. For instance, Rev API, as upstream, you may say, I did Rev API and I did cross-version testing, and there were, trust me, no, don't just trust me and trust Rev API and trust cross-version testing to know that there were no API breaking changes. So we could document this, and there could be some data log layer that integrates all the tool outputs and reasonable outputs. So it's not just necessarily that downstream has to look at the machine readable certificate. There's a tool that tells you, yeah, everything's fine. And so we can wrap up here. And the vision is, let's make dependency management easier. It sucks, no one really wants to do it. So maybe it doesn't have to suck as much. And now is the time everything can be automated. And so we can really develop some potentially high leverage tools here. We have incremental analysis, we have infer, we have not that data log, we have the other data log as a tool, and perm analysis as a service. And yeah, this is a call to action. Contracts, taxonomies, API services, and human factors. All these things have some contribution to this program upgrade call. Thanks. I was looking at this talk that I gave recorded, and I'm like, I'm wearing the same shirt as those 2 years ago.
All right, thanks for the talk. I'll grab the mic from you and bring it around for questions, and you can stand next to the staff there. All right, question down here.
Hey, thanks for the talk. Seems to me it would be incredibly useful to have data on how often we're getting these breaking changes, these unexpected, undocumented breaking changes, and what causes the different, how relevant the possible different causes are in practice. Do we have any data like that?
I am not aware of any data like that. I'm just aware of sad stories that people tell me sometimes.
Can you collect some, please? That would be a really, really useful start.
It would help if someone worked for a company that collected data.
That would be a brilliant thing that somebody could do. Maybe me, maybe you.
Another question?
Really like the vision. Thanks for sharing. I want to maybe underscore and slightly expand on taxonomies as yeah, as being helpful for research. I think you mentioned kind of taxonomies as inspiring tools to cover the different parts. I've actually used taxonomies to evaluate tools as well, right? Because it's nice to, when you build a tool, it's nice to make a claim, oh, the tool covers these different things, right? So I think it really moves the research forward, and taxonomies can be a lot of work to do well, but I think there's an impact on the community, and also, then everyone cites them, so we should do more of this.
Yeah, it's kind of this thing that is a lot of work, right? But people will read them if you tell people about them enough, and eventually people kind of get the message, and yeah, they cite you.
Yeah.
Cool. See, well, let's go here and then there.
I hope that a lot of us have actually thought about this, and there's no good on, it's a really hard problem. Have you looked at the different, let's say, API specking languages, or specking environments, or even data specking, and analyzed them at all from the quality of those languages in terms of how they support changes and notifying of changes, and there's qualities of very low expressive languages like data modeling or API specifications, where I think we can say a lot more about the exact type of changes that can and cannot be made, and even the gray areas.
So like changes or type systems like non-null are one example of a thing that actually could be helpful with upgrades. Specifications like the thing I did for my thesis 20 years ago would not be that useful for upgrades, or like JML things I think are not that useful. And so I think for every particular specification system, you got to think whether it could be useful for upgrades or not. And sometimes the answer is yes, and sometimes the answer is no.
Yeah. So I mean, a concrete example would be protocol buffers is more. You can do more static analysis on protocol buffers in terms of upgrade than you can on JSON schema.
Yeah, for sure.
And one of the reasons you can do that is because JSON schema is actually technically more expressive than protocol buffers.
Yes.
And then there are other languages that have defaults and all sorts of things in them that are even better.
Yes.
And quite possibly APIs defined with dependent types would even be better.
Yes. Yeah. No, that's, I think, good insight.
You mentioned JML would not be a good choice.
I don't know. I mean, like if you're just saying I added a thing to a list, then that's not particularly useful as a spec that you might want to know about for a change.
From what I could tell from your talk, you're basically assuming that the upstream would actually make some effort to try to tell downstream what's changed.
It doesn't have to be upstream. You could have a third party come along and say, I am analyzing changes.
Okay, because the question, does it know some of my colleagues at my job?
Yeah,
It very much depend on something that they'll just make break changes and patch updates all the time, and very notorious for just changing everything as they please. I was thinking they'd love it if they had something which could tell them that the breaking changes, but the people upstream are not going to be doing that.
Yeah, as with anything, right? You can always have some guy going around and doing chaos, and someone else like going and cleaning up after them. And so this is that would also work with this vision as well.
All right, is there one last quick question?
I try not to be the guy running around doing chaos. My advisor on the other hand.
Not doing the cleanup.
So Patrick, I think at the beginning you sort of talked about you're damned if you go too early, you're damned if you go too late. But then at the end you were sort of talking about certifying that this is not a breaking change or not, which doesn't seem enough to sort of get at the quantitative message of, or measure of, should I upgrade now? Sort of, what's the benefit? What am I, you're starting to estimate what's the cost of me upgrading now because of how many semantic changes there have been. But it's not telling me, are these semantic changes that are getting rid of a critical vulnerability or sort of sort of the benefit side of the ledger instead of just the cost side of the ledger? Or do you see that, or am I misreading?
I could imagine a system for announcing changes which includes both the costs that you are not going to incur, right, which is what we're talking about, but also the costs that you would incur by not upgrading right away, right? It's like if you don't upgrade that right now, you are going to be vulnerable to a buffer overflow, right? So that could totally be a thing.
All right, let's thank Patrick for the great talk.